All right, ladies and gentlemen, we're back with our first compute the following limit using any of the techniques discussed in class. And I don't want any decimal approximations. Okay? So the first thing you should always check is my limit a domain issue? If I can just straight up plug in -3 and get a legitimate value out of that, not an undefined value, then do it. So you should always plug it into the bottom of a fraction to see what happens. So -3 squared, that's 9. 9 minus 9 is 0. That's a divide by 0 error. So what we must do is we must figure out a way to either use factoring or the conjugate or some means by which to cancel out. If x approaches -3 is the issue, then we need to cancel out x plus 3. That's what that means right there. So the bottom is a difference of squares. I can factor that. This would be x minus 3, x minus 3 multiplied by x plus 3. Okay? The top, we are just praying that this thing is factorable. Let's check it out. 2x squared plus 7x plus 3. If you've forgotten how to factor, what are you doing? No, I'm just kidding. The AC method works out pretty fine. 2 times 3 is 6. The b value is plus 7. It's 1 times 6. Checks out. So what you do is you take this and you split it up into 1x plus 6x. All right, because 1x plus 6x is 7x. I didn't fundamentally change this polynomial. I just rewrote the middle as 1x plus 6x. The 2x squared is kind of still there, and so is this 3. Then you factor by grouping. You take these first two and say, what can we take out? You can take out an x. Leaving you with 2x plus 1. Check these out. What do they share? They share a 3. You take that 3 out. You're left with 2x plus 1. Therefore, x plus 3 times 2x plus 1 is the final factored version of this thing. I'll tell you what, if you're really struggling with this, day 136, 137, and 138 for Math 1 are videos that are going to be on YouTube. I show how to do this multiple times. Check it out if you're struggling with it. Otherwise, we factored it. The x plus 3 on top cancels out with the x plus 3 on the bottom, which means we can now actually compute the limit as x approaches -3 of 2x plus 1 over x minus 3. All right, so this right here is kind of like in its own little bubble now. It's not a bubble, but you know what I'm saying. You can just plug in -3 because it doesn't create a divide by 0 error anymore. -3 minus 3 is -6. On top, 2 times -3 is -6, plus 1 is -5. The answer is 5 over 6. All right, checking out the next one. The limit as x approaches -9 of x minus 9 over x squared plus 81. Your first task is to just plug it in the bottom to make sure that you actually do have a divide by 0 error at the spot where you're trying to compute the limit. So if I take -9 squared, I get 81. Oh, 81 plus 81, that's 162. I can just plug the limit right in. -9 minus 9 is -18. And then that should simplify because they're both even, so I can cut them in half. That's -9 over 81. And then -9 over 81 is -1/9. See, I think a lot of you guys would probably try to do a difference of squares factoring with this thing. Like you'd say x minus 9, x plus 9, but it doesn't factor that way. And because it didn't create a domain issue, you can just plug straight in. That was number 3. Number 4. Oh, those pesky square roots. Well, check it out. Does plugging in 0 on the bottom create a divide by 0 error? Yep. Okay, so we got to do something different. We can't factor this one, but we talked about how multiplying by this thing called the conjugate will actually, Will actually get rid of the square roots on the top, creating a potential I can't think of words right now. A potential simplification of the x on the bottom. So, what I'm going to do right now is multiply by the conjugate of the root value. So, root 1 minus x minus 1. Its conjugate is root 1 minus x. We're not going to mess with the actual square root itself. We're just going to say it was minus 1, multiplying by plus 1 creates a difference of squares. And you got to do it on the bottom too. So now, a difference of squares. Think to the last problem where we factored x squared minus 9, or number 2. This is x minus 3 times x plus 3. Think of them as conjugates. When I multiply x minus 3 times x plus 3, I don't have to go through the whole rigmarole of x times x times 3, negative 3 times x, negative 3 times 3. Because the pattern is that you can square the first, square the second, and make sure there's a minus in between. So that's exactly what I'm going to do on the top here. I'm going to square the first, which means just get rid of the square root. You square a square root, the root disappears. 1 minus x. That times that is 1 minus x. Square the second, 1, and then slap a negative in there. That's just how conjugates work. It's the reason why we multiply by the conjugate, because it simplifies things so nicely. On the bottom, I'm going to ask you guys not to distribute this x because we're trying to cancel that factor. Keep it, quote, factored. All right, that 1 minus 1 on the top is going to eliminate 0. Bye-bye. And then negative x, it's kind of like, think of it as it's a negative 1x. Yeah? So x divided by x is also 1. It's like 1 over 1. Yeah, negative 1 times 1 is negative 1. It basically cancels out, and there's no remnant of it anywhere. Now the 0, it's gone. That means that the domain issue is now gone, and we can plug our limit in. So plug 0 in for the x down there. There's no x on top, so it's root 1 minus 0 plus 1. 1 minus 0 is 1. The square root of 1 is 1. So this whole thing right here is 1. 1 plus 1 is 2. Negative a half. Is our answer to number 4. Yeah. By the way, check out the other videos if you feel I'm going too quick on some of these steps. Like, we talked about the conjugate more in depth earlier in remote learning. So make sure you know you have that resource at your disposal. Number 5. The limit as x approaches 7 of 5 minus 3x. What, is this a joke? 5 minus 3x doesn't even have a domain issue. I could plug 7 in right away. I guess I got to know my order of operations, but come on now. 5 minus 21, that's negative 16. Bam. You got to knock those out of the park, okay? Number 6. Uh-oh, we're coming from the left and the right now. Got to put our thinking caps on with this one, okay? Now, if you recall, we had two rules in which any function in which you cannot cancel the domain issue. You have to think of it in terms of, oh, there's an asymptote there. And all asymptotes have the same behavior if you can isolate it to 1 over the domain issue. So we're really computing the limit as x approaches negative 3 from the right of 1 over x plus 3 times the limit as x approaches negative 3 from the right of whatever other part of the function composed the original. So 1 over x plus 3 times 2 over 1 is what would give me this function right here. So I decomposed, I broke apart the original function to have this part right here. The reason being is because if it's coming from the right, that always yields positive infinity for this particular part. And then all we got to do is multiply by whatever this non-domain issue value is. So there's no domain issue here. In fact, if it's just a constant, I can't plug in for x. It's just that constant remains. So it's infinity times this limit equaling 2. And if you double infinity, it's basically just approaching positive infinity. And that's your answer. Now, what about one that's a little more involved, like number 7? Well, our purpose, or not our purpose, our goal is to get whatever creates this domain issue apart from the 3 minus x over x squared minus 25. So I can factor the bottom of this thing. The bottom would be x minus 5, x plus 5. And this is usually where I would like color code things and say, look, this is the one that's red, x minus 5. It's the one that if I took 5 minus 5, I would get 0, a divide by 0 error on the bottom. That will not cancel out with anything on top. So what I'm going to do is I'm going to rewrite this function as 1 over x minus 5 times 3 minus x over x plus 5. And the way limits work is that the limits can infiltrate this decomposition of a function. You can say it's limit as x approaches 5 from the left here, limit as x approaches 5 from the left here, and there's no big issue there. So now, from the left, if you can single this part out, won't be positive infinity, it'll be negative infinity. Over here, there's no domain issue, so you just do a straight plug-in. 3 minus 5 on top, which is negative 2. 5 plus 5 on the bottom is 10. That's negative a fifth. So it doesn't matter what this value is. All we're looking at is the sign of it. Oh, I take a negative times a negative infinite value, and you get a positive infinite value. So that one's positive infinity. All right, number 8. Oh, we got one of these piecewise functions. You guys love those piecewise functions. Maybe? Yes, you do. This is where you have to determine which part of the piecewise. Well, first of all, make sure that the place where the piecewise splits is actually the limit you're approaching, because that can cause some issues sometimes. But since 7, okay, it's at 7. From the right, one of these describes behavior from the right. Greater than means from the right. Less than means from the left. So here's our right function. So you're basically just saying, oh, what's the limit as x approaches 7, from the right, of 3 minus x squared? Yeah, so you just plug it in. negative 46. All right, stopping the video.